Thank you. Hello everyone. We have a really nice space here. Feels like there are a lot of parties going on. And so, my name is Adam, and I'm actually Serbian, Croatian, whatever. And I studied in Vienna with Greg Lynn, young Monte, and that was like graduated 6 years ago. And I've been around, so I've traveled. I've worked in Vienna and London and Los Angeles, and I worked in Sweden. But finally, in the last 3 years, I'm based in Prague, where I run my small practice, and I also teach and do research work. Okay, so tonight I'm going to show you a lot of things, many of things that you forget, but I will talk mostly about performance in the context of multidisciplinary work. I'm mostly interested in performance as a notion of simulation and perception. Within the simulation, there is the connotation for computer fluid dynamics, so you can relate the simulation to computation. Then the simulation as a system behavior, so the natural systems that occur in biodiversity, and the material behavior. And in the context of perception, we have visual expression, the context slash topology, and finally the virtual perception. Now it's important to kind of understand that these divisions interact with each other all the time through all of the projects and the research work I'm doing. Particularly, they are inputting each other through parametric notion, but not parametric design per se. I hate that. But parametric as a mathematical sense, right? So as a mathematical work. And the topological input, which is basically sculpting. Okay, so just before I go into the projects, I just want to show you kind of a historical context of the simulation and how it's very important for the computers itself and today's digital environment. Of course, the simulation for the first time appears in Plato's work in Allegory of the Cave 4 centuries BC, and probably some of you know already, but simply put, the Allegory of Cave is a simulation as a, to translate it nicely, it's basically a matrix, right? So the whole world is in the simulation, and in this particular case, it's about people who are inside the cave. There are shadows projected on the wall, and they only see the shadows. They're not able to rotate and see what makes the shadows, and especially not able to see who is making the content. However, they are like through philosophy, of course, through Plato's definitions, through philosophy and through explorations and theories, in maybe modern context, it would be through science, is where we are able to rotate and understand, or kind of get revealed, right, to the content, or like to the kind of deity of understandings. Okay, so fast forward, we have in 17th century Francis Bacon, the guy who kind of wrote the book on scientific methods, who talks about the simulation more in a kind of negative context, as basically word for lying. And then later on, in mathematics, for the kind of true sense of how we understand it today, the simulation, the Buffon's needle problem, where they kind of, through the simulation, calculated particular equations for the P number. Okay, and then in the 20th century, there's kind of an interesting development during the war, actually. Of course, the British, they were making the Turing machine, and as a kind of correspondence to Enigma, right, machine that was coding the messages. And at the same time, the US government was also making a machine called ENIAC, Electronic Numerical Integrator and Computer, that was simulating ballistic trajectories, right? So they were simulating the curves of the missiles. These ladies, there were 8 of them. They were actually physically programming this machine, and they were called computers. So, of course, at that era, it was all about the atomic power. So the computer was firstly mainly used as a weapon, but the simulation aspect continued into aviation industry and boat industry, where they used the computer fluid dynamic systems to calculate the dynamic systems of the airplanes. Okay, so just a second. I will show each project in the context of these several types of the definitions I was showing earlier. Here we have my thesis project, the binomic perceptuals. It's a tower essentially in Zagreb, and I'm not going to talk too much about it. It's a giant radiator, right? It's a very smart radiator. But essentially, I took like all the information of ecosystems in the context and run parameters through ANSYS software to get the proper velocity of the wind and the pressure of the air, in order to, and then combine that information together with a program to essentially create a kind of a smart facade that differentiates along the entire height according to the pressure values and the velocity of the wind. That kind of then differentiates and creates a completely visually kind of unique appearance of the building from every single angle. Okay, the next project we have also from the Gregorian class. This was actually one before my thesis. I did it in a group, but it's a boat fabrication yard in Croatia on the island called Cres. Now, there was already existing boat fabrication yard next to a very small Venetian type city. You can see here the context. So you have this kind of very small buildings nested closely to each other, typical for the whole Mediterranean. Basically, the reason why they were building it like this is due to the weather, right? So in the winter, or let's start with the summer. In the summer, you have a lot of heat, so the thick walls and small windows prevent the heat going inside the buildings. While in the winter, when there are a lot of winds, strong winds, again, the kind of meander type, the labyrinth type of the streets prevent the wind going through the city, through the urban matrix. So here actually you can see this is the site, and we have two main winds. One comes from the coast, it's called Bora, and one comes from the sea, it's called Shiroko. They're really strong, like the Bora can get up to 150 miles per hour. So, in kind of, basically, just a second, I will see one slide, yeah, doesn't matter. Okay, so, typically what you would do is, with any kind of factory, you would have kind of a single floor plan with a single roof that accompanies all the program inside. So, putting something like that, something so huge next to such a kind of picturesque city would be a crime. So here we kind of investigated the situation where you would divide all the program into single units and then work with the figure-to-figure relationships and the figure-to-ground relationships in order to kind of respect the urban context. And then once we were once we found these relationships that we liked, we ran it again through the computer fluid dynamics in order to test how the wind behaves once it hits these kind of figures. And according to the information, we then went back and remodified the geometry so that it can kind of prevent these pockets where you would have maybe the wind increase or completely kind of stop the vortex coming behind the geometry. Okay, so finally, once you put all together on the site, you have this situation where the front part of the building corresponds completely to the winds coming from the land, while the back side of the building that goes onto the sea responds to the wind coming parallelly from the sea. Also, the wind situation is what drives the kind of heating and cooling system of the whole building. So it's all kind of integrated into the building technology. All right, the same thing, Taiwan Tower competition entry in 2012. Here it's something else. This is when you take something as banal as a chimney and apply that system on such a large building. Now the chimney, of course, you should all know, it's all about the pressure difference between the bottom and the top, right? So the taller the chimney is, the faster the wind goes or the air goes through. So, and you can increase the speed if you have the chimney made out of glass and you have sun heating up this glass, right? So the more heat, again, the faster the wind goes. So if you actually put the turbines in the bottom, below the ground, and you let the air go through in this way, you generate electricity. Okay, so I'm not going to go too much into details of the building itself, but it's essentially an exoskeleton structure. Okay, this is a project I worked for in an office in London called Atelier, and I was working there for 2 years, and I was assigned on this project the whole time, kind of. And they asked me to do. The office already won the competition for an educational building, and in Bahrain. And but the client did not like the facade, so they had to come up with a completely new design for the facade. So I was assigned this task, and once you start working with Islamic patterns, you realize that I mean, you cannot lecture Arab people about mathematics in Islamic patterns, right? So you can be very creative and do all sorts of patterns, but they know everything, and it's really hard to find the right one, the unique one that they would kind of appreciate, and that would also, in the same way, differentiate their project for any other in the Middle East, especially when it's a very kind of important building, public building. So my idea was to work with hexagons, and in the same way to kind of visually hide the fact that it's made out of hexagons. So when you take like a normal kind of geometry and you just repeat it in a normal fashion, you actually see the repetition and you see the hexagon pattern. But once you start to rotate by 60 degrees each, and you place them in a specific way, you lose actually the whole hexagon pattern. So for the project, there were 6 types of the components of this facade hexagon panels. And then again, according to the sun heat and shading, and according to the program in the back of the building, once you kind of overlay that, you get this map that corresponds to each density of the panel. And finally, you get kind of a smooth gradient differentiation of the pattern across the facade, and you lose this hexagonal appearance. Also, the hexagon has the K inside, letter K, that kind of corresponds to the last name of the client. So here we go. There's that's the mock-up. It's made out of glass reinforced concrete. So it's special concrete that basically all these kind of filigree small details you cannot do with normal concrete, right? So you have to introduce glass fibers inside, otherwise it will break down. And then, since the facade was kind of accepted, we translate the idea of this pattern on different scales along the interior. So you have the kind of suspended ceiling that is the negative of this K pattern, and then the cuts of the stones in the ground are also made in the same way. And then we have the mashrabiyas, which are kind of the smallest pattern, and also the light diffusers, like kind of an intermediate pattern. Okay. More. Next project again with dealing with the weather and context in the same way. This is a huge competition in Serbia, near my hometown, on the north of Serbia, called Palić, and the competition was for the resort that included spa, aqua park, and a hotel. So like 80,000 square meters. And I mean, I know this place, I grew up here, so it's a very beautiful place. It was actually a kind of escape resort for Austrian-Hungarian Empire family, right? So like 100, 200 years ago, they were using this space for recreation. And a lot of architecture dates back from that era. So it's kind of very beautiful, picturesque place with secession and Jugendstil all around. So for, again, similar to both application yard that I was showing earlier, it was all about breaking up the huge mass into smaller pavilion-like shapes that would kind of directly correspond to the specific views along the site. So you have these kind of several approach dots, or like the points, from where the building almost kind of disappears or appears to be very, very small. So we have basically in the middle, we have a hotel, and then down we have aqua park, and up north we have a thermal bath. And that's the kind of whole length is almost 1 kilometer long. Alright, so those are the renders. And the reason why I'm showing this, again, the facade was run through the Ecotech, and we were kind of calculating the presence of the sun. And again, in the correspondence to the context, so to the roof of existing structures, we kind of created the facade that was kind of differentiating, but all the panels were flat, so it would be cheap to produce, but they were still differentiating in X, Y, Z axis to either allow more sun or complete shade from the sun. All right. So now we have work of my students. And this is actually the project that we did in Lund School of Architecture in Sweden, where it was presented at Slovenian Pavilion for Venice Architecture Biennale in 2012. And here it was all about the natural systems, right, and the behaviors in nature. So students were looking in different kind of systems for, in this case, the swarm behavior. And again, kind of studying the swarm behavior, studying the kind of motion paths and the influence in different kind of containers. And eventually, when you put that into the context, the swarms were recorded, right? Their path was recorded, and along those curves, there was a geometry that essentially kind of aggregates. Or in this case, the student was looking into a cluster of ants. So single ant would drown in the water, would just flow down, but when they are grouped together into kind of a big cluster, they can actually float because of the buoyancy on top of the water, so they survive. So looking at this kind of system, the student essentially created these large urbanistic structures that work with the existing river on the site. And again, because the river floods, the structure behaves in the same way as the ants behave, so they kind of gather together and interact in order not to float down. I hope you guys see because I'm standing on the way. Okay, so this is the again student project from Prague. Here we have a different situation. Here again we were dealing with Vltava and recent floodings, and the site was on Kampa, you all know, and Museum Kampa. So the students were looking again into morphology of different kind of structures and forms and behaviors in correlation to the water. And again, the students were, in this case, looking at mangroves and how the mangroves prevent the flooding of the water. And applied that system to the Kampa site. So you can see there, that's Museum Kampa, and you actually kind of cannot see the rest of the Prague because it's underwater. So only this place survives. That's a kind of swamp-like structure. Maybe I should sit down so it's better. Okay. And the next project was also looking at existing strategies for preventing floods, or like let's say the debris that accumulates during the floods and the debris that destroys other structures. So if you look at the Charles Bridge, you see these wooden timber kind of structures in front that would kind of prevent large garbage inside the water hitting the bridge. And also next door, or like a few meters next, Karlovy Lazne is called the area, you have something similar happening in this structure. So again, the students were looking into modifying that kind of topography and apply that on Kampa site and essentially allow people to use this kind of structure during the flooding, right? So you can use the site while there is also flood. Otherwise, right now when there is a flood, they just cut off the half of Prague and you cannot move. It's a complete chaos. Okay, and then again dealing with the Vltava, but in a different kind of way. Here it was more about aggregating ice on different kind of structures. So basically, you have a kind of filigree structure that in the summer allows a lot of kind of steam going out, or like let's say small particles of water, allowing cooling of the mass being people. And in the winter, the ice accumulates on the structure to create enclosed spaces, cave-like spaces. So here we have a small video. The student was testing. This is called a supercooling ice technique. So the student was not waiting for weeks for ice to actually build up in the fridge, but with this very simple technique, he was able to generate ice very quickly. And then again, that same method was simulated inside the software. Okay, now this whole perversion with simulation I got interested in when I moved to Prague, actually, because I got in love with glass behavior, and I mean, you Czechs are just kind of amazing with glass. So I looked a lot at the process, and I wanted to simulate glass behavior inside the software. So this is just an excerpt from last week. It's interesting that glass blowing technique did not change for the last 2000 years. So nothing really changed in the process. So you have the glass blowing masters that use the kind of air pressure from their press and the mold, the optical molds, to shape and form particular designs. Okay, so for this particular research, we separated. I worked with some students as well on this project. We separated the technique into four areas: the glass blowing, slumping, fusing, and cutting. And essentially, this is what happens when you simulate the glass inside the software. So what you would do, normally you would make a sketch. You would go to a glass blower, and they would do try and error period where they would spend a lot of time, and they are actually very expensive. So they would work a lot until they would achieve the design that you like. But with this kind of approach, the idea is that designers, and particularly architects, understand the behavior of the material and are able to predict the behavior in advance. Right? So before you would even go to a glass master, you would already know how to build the optical mold, how to build, or like how much material you need, and what kind of effect you are able to achieve. So it's essentially a virtual prototype. There's some more. The slumping is the similar technique, but what happens is that you put like a flat sheet of glass into the oven and you let the gravity deform these kind of like shapes and patterns, again in correspondence to the mold below. And for this we also did some tests. It works really nice with the light. And here are some preliminary design prototypes done in this kind of way. This was something more complex. The glass, when it's heated up, it's actually it behaves as a glue, so you can attach small particles on top of the surface. So this is kind of simulating rolling, the same kind of rolling as they would do in reality. Okay, so here we have similar technique, but for different type of the project. For the experimental architecture biennale in Prague, that is finishing this week actually, we did last week a weekend workshop where we simulated the behavior of this EVA material. It's essentially this most kind of a gun-like material that is really nicely forming when you fold it. There is existing structure already as a part of the exhibition setup done by Martin Sandner, who is a curator. But we had a lot of material, so we used that in the process of building another installation for finalizing the exhibition. So essentially, again, we studied how the material behaves when you fold it. You can create really nice shapes. And then again, students were simulating that fabric behavior inside Maya. So normally what you would do in this process, I call this simulation-based design. But normally what you would do, you first do a design of a complex shape that you unroll into a flat surface, but that flat surface is never kind of a complete square. Here is a kind of reverse process where you have the square sheet, and you take that square sheet and you bend and fold inside the software to achieve the desired shape. And then once you kind of gain all the desired shapes, you complete the design, and then we chose one design of a student. It's kind of a winning project, and she built the whole thing in one day, and we have set it up this week. Alright, now that was all related to simulation. I'm going to talk a little bit about emergence of perception, and show three projects related to perception. Of course, we have perception as a kind of instrument that informed architecture throughout the last 500 years. Especially it started in the Renaissance with the discovery of linear perspective and Brunelleschi's work. Of course, many architects and artists like Bernini, Alberti, and Bramante were using the technique of kind of visual perception as a way to cheat in perspectives on different scales. Right? So, for example, in Piazza San Pietro, the trapezoid shape of the whole square is due to the fact that from one side, or from the side of the Pope, you see the deformation of the whole square appears as a kind of wide normal square. Like square as a square, not square as a, you know what I'm talking about. But here we have a Palladio with particularly interesting projects, and the fact that they introduced these kind of effects in theater performance. So the Teatro Olimpico that works with the golden ratio, and as well with the backstage, where the backstage, as you can see here on the left, scales down, so that from the audience view it appears much further. So you gain this depth, and that's again due to the manipulation of perspective. And some other work in 17th century, this is the Hogerstein, the peep show, again kind of cheating the visual perspective and appearance of the small box that looks like it's very deep. Okay, so throughout the history and the technology, this kind of manipulation of techniques, we have most notable projects in the film industry that kind of use the same thing. The Schumann's process, for example, is using the camera and the mirror to overlay a model, a small-scale model, with the real scenes. So this is kind of this is essentially fundamentals for the green screen, right? And then fast forward to this century, the Avatar and James Cameron, again, he developed completely new cameras that basically revolutionized the way how we use the cameras, not only as a kind of 3D rig for shooting stereoscopic images, but also virtual camera, right? So a camera that is only, you hold it only as a digital screen, and it has these tracking points that track your position in the space, and basically on the screen you see the digital world from your exact point. So it allows a completely new maneuverability inside the film. So I was very interested in the 3D technique, and after I graduated with my colleague Julia Korner, we won Max Schindler Scholarship to become a kind of architects in residence in Los Angeles and do a 6 months research project. And of course, we were very much interested in the 3D technology that was it was just like after Avatar. And on one hand, on the other hand, we explored the biodiversity of morphologies of California, because California is one of the most biodiverse places on Earth. So basically looking in all the natural structures and the patterns that we can find. So here we explored different types of systems and through different types of media. These are for the lenticular prints, for example, but essentially we realized that when it comes to 3D image, it's all about layering. So, for example, this is the Gravity film in 2013, and it's considered to be kind of the best 3D film ever. And the reason for that is because in these particular scenes you have millions of small parts, and they all behave as a kind of a single layer, right? So the more layers you have, the more depth you have in the image, and again the visual experience is much nicer. You have the same in the Great Gatsby with all this kind of flickering stuff going on in the parties, but I regret for seeing this movie. Okay, so here we have the lenticular print. That is again exploring the medium of a 3D image without wearing the 3D glasses. So the print is actually behind a special lens that allows that, and I try to kind of record that. So when you see it, when you look kind of through small angles, you can experience that depth. Actually, this was when it came out after Avatar. Some phone companies apply this kind of screens to get this kind of fake 3D effect, and also television sets were coming with this kind of 3D lenticular screens. Okay, some more process. I'm not going to talk more about this, but it's again all about stimulating the growth of natural behaviors. That's Greg Lynn. Alright, so after that, I applied the same knowledge on the work with students to experiment different kind of techniques. So in this case, in Sita in Denmark, we did a workshop where we worked with their project, which was about the inundation, so the flooding of the site, and students built these kind of simple landscape models, the topographies, and then we map projected 3D content on top of the simple geometry. And then through videos. So what it does, basically, it kind of since you have this 3D image on top of the 3D model, and you can, even though the model is relatively simply made, you can experience the geometry in a very complex way. So you get all the details. So again, it contributes to this notion of virtual prototyping. Something similar happening with the AA visiting school in Paris, where we worked with the fashion design, actually. And again, working with the 3D stereoscopic cameras and glasses to generate the geometry that was experienced in 3D. Same here with the scopic assemblage workshop in Lund, in Sweden. Again, the workshop was about the relationship between the part and the whole, something that is very kind of prominent in the architectural discourse. And again, through the layering and the notion of small parts versus large parts, the students were experiencing the whole design process in 3D inside the software without building physical models in kind of early stages of design. Okay, so when it comes to visual experience, this is the competition I worked on for art installation in Los Angeles. And essentially it's a surface made out of small pyramids where each pyramid has 4 sides and each side has a different color. So once you kind of rotate around the object appears in different color from every single angle. Animating the whole building up process. And a kind of tensional structural concept that allows through the particular kind of strings manipulation allows the structure to achieve different general shapes. This is another project I was working in Prague. It's the I worked as a production designer for commercial for the car Infiniti, Crew 50. So let's see first the commercial itself, and then I'll talk more. It's a little bit distorted, but I worked on all the robots in this commercial. It was shot outside Prague. Escapes. Alright, so as I said, I did the robots, the design and fabrication, and then some of them were actually, I mean, they were all articulated with articulated joints, so completely kind of maneuverable, but most of them were just kind of puppets, right? So there were guys that were pulling the strings to allow robots to move. And then in post-production, they were manipulated further for the final result. But what was interesting in this project is this kind of overlay in the film industry of virtual and physical world, because they had to build the entire set very quickly, and well, everything was, I mean, it was a large budget, so they did everything in like 2 weeks. But usually, you know how we do it in architecture, that you would prepare all the plans and it would go to a builder from architect and then to the construction site. A very long, narrow, linear process. But then here, they kind of have millions of people, everybody do a small part, they come to a site, they build things, and then along the way they improvise because nothing matches. But finally, they shoot the whole thing. And during the shooting, the post-production guys, the CGI guys, they were there, and they had these surveying cameras, right, like the geodets guys have. And they were measuring the entire set and basically rebuild this physical world in a digital world again, and then made the whole post-production process like that so that it matches. All right. I'm also interested in small-scale work. I have kind of fascination with the lamination in the carbon fiber, and I did this small coffee table experiment that essentially works as a, well, it's a kind of, everybody finds a different shape in it. My initial kind of thought was the relationship between the small scale and the large scale. So I see, again, it's this kind of part to the whole relationship where a table is against something, is a part of something much larger, right? So, again, through simulating and molding, I created this laminated single piece of table. Okay, and last project. So, for I exhibited at Experimental Architecture Biennale in Prague right now, and the work for that I did is actually something that I'm working in the last few months. You probably all know that virtual reality is coming back from the graves of the 90s, and it's actually interesting because in the 90s it simply did not catch up because the technology was just too crude. So after like a few minutes you would completely get sick, and it never caught up, apart from maybe NASA and some high-tech guys who did work with it. But in the last few years, due to Oculus Rift, we actually had, due to the development of both the sensors and the screen, we are now having a brand new technology that is coming. But right now we have it as kind of developers kits, but next year we have products that we are able to buy commercially. However, there is still no content for virtual reality, right? So there are still gaming developers who are building games and artists who are doing some kind of experimental films. So I'm one of those guys who is just telling me to stop talking. So I'm one of those people who are actually doing the content for new content for virtual reality. So, as I said, it was kind of used by other industries apart from gaming companies, and it's very interesting because if you imagine where the technology will move in the future, it really kind of influences directly architecture. Because if you imagine that in the future everybody will wear these kind of glasses, I mean, you can right now strap your mobile phone in front, and you have virtual reality, so it's kind of very simple. Basically, it means that you can augment and overlay, especially also if you look at Microsoft HoloLens, you can overlay the digital information with the physical world. So if that means that you can actually manipulate the details in the digital world, essentially it means that perhaps the physical world can be left blank, right? Or can be detailless. Or that's just a question, I don't know. That's what I'm kind of experimenting with. But it's interesting because like artists like John Gerard, this is a computer-generated image, right? So of an existing place. So he's a photographer, and he went to Google's data servers, I think in Utah, and took photos, and then rebuilt the whole thing in 3D and rendered in a hyper-realistic way the image in a really high resolution of that same image, right? So this is all kind of digitally made. So you can see that this is also work from him. You can see that image quality, right, is also increasing. So at one point you will just lose the boundary, right? The boundary will blur between what's real and what's not. So for the installation and the exhibition, I worked on a project that was site-specific because I knew exact position of the iPad that I'm presenting on, and with the gyroscope of the iPad, I just built a 3D space of the gallery and quickly manipulated the ceiling and the floor in this animation. So this is it's also interesting because it's a spherical camera that's unfolded as a flat surface. So right now on the flat surface you see all the angles of the space. Inside the software for the viewing, right, for the VR, you can actually look around and see all the angles. So as a kind of, if you use it as a design process, that's also part of my exhibition manifesto. If it's about showing a new way of let's say representing the project in a new way, it means that if this becomes a standard, essentially you're not anymore able to hide any mistakes in your projects, because whenever you're rendering with a spherical camera, you are showing the entire space in your software. Okay, so these are the works that, apart from the exhibition that I'm working on. Unfortunately, I cannot tell you much about it because I'm under contract, but I can just show you. So again, that's it's left and right eye, right? So it's two cameras, stereoscopic rig, and unfolded here in a flat image. So, yeah, I'm kind of both optimistic and sometimes pessimistic about the future, but I do imagine the future where the kind of the boundary between the digital and physical world will completely melt and become one, and like through the kind of innovation and new technologies, I'm interested in applying that knowledge to the architectural environment, but always being aware of other disciplines that are kind of constantly informing my own work. And I hope that, and it's also on the other hand, it's also, you can see it as a kind of economical model, right? Because with all the tools, all the designers and artists and architects today, I mean, we're all using the same tools, right? And you can actually see that in all the work. So that essentially means that, you know, if you finish as an architect, you can work also as a fashion designer. And actually, there are fashion designers who are architects right now, really kind of bringing the new technology, 3D printing, for example. But in a way, it's very important to kind of you know, have this wide view on what's going on, and I hope that some of this work would kind of maybe inspire you, or I mean, you can also get it if you want, I don't care. But that's it, yeah, thank you. I'm sure, I know I was talking fast and perhaps something was not clear, so I'll be happy to discuss or answer questions. Shoot.
If you have any questions, I will pass the microphone.
thanks for a great lecture. It's very amazing. I have a question for you. If you are interested in this virtual reality, and how do you see like the possibility to transform the architectural language to maybe to a total new way, to not like bring some kind of past things into this? And what could be, let's say, new impact of doing this?
Well, yeah, so that's what I was trying to say a bit earlier, but I'll try to kind of be more specific here. It's also something that I'm trying to answer for myself, right? Particularly if we can imagine that in 20 years, you are just wearing something on your head, and you are able to overlay any digital information with the physical world. It means that the detailing of the architecture itself, right, of architectural spaces, on all scales. So coming from from product design and the glasses to the streets and urban level, it means that the kind of actual detail that exists does not matter anymore, because it can be changed, right? And then every single person who has something like that on his or her head sees something different. So if it's about that, then what's the relationship between the architect, right, who builds the space, and the user? So I honestly don't know right now, and I'm kind of trying to figure out if it's something that if it's about creating a space that in a way corresponds to this notion, right? Or if it's just about leaving the blank space. I don't like leaving just the blank space. I'm totally against it, and because it's just the most easiest thing to do. So, what happens when you actually kind of take off the glasses and you see the reality? What is the reality? And that's something that I would like to kind of find out with the work that I'm doing. I don't know.
Okay, if you don't have any more questions, I would like to invite you to more informal discussion to the bar, and we'll continue with the program at the DJs and after party.